And welcome back with us inside the International Space Station Flight Control Room. As you've been watching, Karen Nyberg and Chris Cassidy have been working with the Spheres satellites on a dry run for competition with students at MIT next week. A different sort of satellite is closing in on the International Space Station in the form of a Japanese cargo ship called the H-2 Transfer Vehicle, or the HTV-4, a big cargo ship due to arrive on Friday morning. And with us today here in the ISS Flight Control Room to talk a little bit about HTV, its operation and upcoming activities, is the NASA lead flight director for HTV4, Ed Van Cise. Ed, thanks for joining us.
Good morning, and very excited to be here. And we've been working on HTV4 since HTV3 departed just about a year ago. So it's very exciting to be this close to being able to reach out and grab it on Friday.
Ed, launch on Saturday was flawless. Can you give us sort of a synopsis of the last several days of activities and preparations by the crew on board between now and Friday for the capture of the spacecraft?
Absolutely. Like you said, it was a flawless launch, and the vehicle is performing very well. It is a longer rendezvous profile than some folks might be used to when they've recently been watching things like Progresses, Soyuzes that are arriving in only 4 orbits, and then Dragon shows up just a day or two after launch. So it might seem a little out of place that HTV takes 6 or 7 days to arrive. Of course, we take advantage of that time frame. We do a lot of the crew training either the week before launch or even while HTV is on its way. So it's still fresh in the crew's mind. Just this week, we put them through their paces in flying the Canadarm2 to get them ready for capture. But as far as HTV itself, there have been a couple of very minor things that the team has been working through. One of them has to do with the latching valves, the propulsion system on one of the strings of its propulsion system, and basically what that is a sensor issue that they've seen very sporadically and not very often, where it'll indicate one position where the valve is physically in a different position, open versus closed. So it's actually been a good test of the integrated training that we've done to get ready for this mission. We go through a lot of different simulated cases on being ready to handle situations like this. The Japanese team has done a very good job investigating what might be wrong and coming up with workarounds. And in fact, right before this interview, we just finished a meeting this morning to make sure we had a good plan in place for rendezvous day. So if you hear us on rendezvous and approach talking about the prop system a little bit more than what you might otherwise have expected, that's just because we want to make sure we have all the right checks and things in place in case the next failure happens. And that's what we always worry about is, and we focus our training on is, okay, the system is designed to handle one problem such as this, and we want to make sure we're ready for that second problem. All that to say, though, that the vehicle is very robust and it's very performing very well in its flight. It's been doing a whole bunch of rendezvous burns to get us to this point to show up on Friday for the ISS.
I think our viewers would be interested in finding out why the 6 days. And it could be 2, it could be 7, it could be longer. Why was 6 days for this rendezvous chosen?
Right. So the unique thing about HTV and some of our other vehicles is that the vehicle has the capability to launch pretty much at any time as long as the orbit path is flying overhead of the launch site. So instead of, let's say, for example, the Progress or the Soyuz 4 orbit rendezvous, not only does the orbit path have to be over the launch site, but the ISS has to be in a very specific place so that shortened rendezvous can occur and all the timing works out. With HTV, it has the capability to do a wide variety of maneuvers on orbit, both changing its orbital plane and then also changing its altitude, of course. And that capability allows it to launch pretty much at any point, and we call it phasing, with respect to ISS. So we don't require the space station to be at a certain point in the orbit. But when you set something up like that, you go from a trajectory that has just a small number of very large burns to get you to that final destination, to a trajectory that has a lot more smaller magnitude burns. And so that's why you're seeing a 6-day rendezvous in this case. And before we locked in the final launch time for last Saturday's launch, we could have actually launched on Saturday or Sunday and still rendezvoused for a Friday capture. But once we picked the exact launch time, then it was set up to be a very specific Friday capture. So Yes, it's a longer profile, but it actually provides a lot of flexibility for the space station program to be able to do the launch and the capture operations.
And one of our social media questions that we received from @Irish Space Blog actually asks, why did the HTV actually lap the International Space Station? It's all about Johannes Kepler, I guess.
Yeah, exactly right. It all has to come back to the phasing, and because of when we launched and the altitude of HTV relative to ISS, the lower you are, the faster you go, and thus HTV went around and did a lap around us, and that all is being set up so that on actually it'll be late Thursday night here in Houston. HTV will show up on the same velocity vector, same altitude as the space station, just a few kilometers behind us, and then we'll go into what we call integrated operations, where it'll make its big maneuvers to come up underneath us on the R bar, if you will, and it'll look very similar to what the shuttle did when it did its rendezvous profile, except HTV will stop underneath ISS instead of going out in front like space station or like the space shuttle did.
And on Friday morning, it'll come up from underneath the space station, and the cupola will be a very busy venue with Cassidy and Nyberg, along with Luca Parmitano, monitoring systems and operating the robot arm. How cramped will all of that be, and how carefully choreographed is all of that activity to reach out and actually grapple the spacecraft and then carefully install it onto the Harmony node?
Yeah, the cupola, everybody's favorite place to be on the space station, and then I know everybody has seen pictures of what it's like inside, and like you said, it's a small place. They do train, of course, here in Houston to do these operations in mock-ups of the cupola, but nothing beats doing it in the real thing. So these last couple of weeks, we have been doing training in the cupola to make sure they understood where their body placement will be for best having access to the different pieces, parts of this orchestra. Really, there are 3 separate roles that all these crew members are playing, and so you've got Karen, who's got to fly the robot arm, and so she needs to be in a certain place. You've got Chris, who's helping her, monitoring the robotic system, so he needs to be able to see that information. And then Luca will also be monitoring the HTV systems, and there's a separate command panel to send commands to the HTV, so he needs to be positioned to be able to take care of that. So having that all laid out in the cupola and doing real training in the real vehicle this week has been really influential in making sure everybody knows where to be and get the job done.
Well, Ed, appreciate your insight, and we'll look forward to working with you on Friday morning. We'll have live coverage twice on Friday morning, starting at 5 a.m. Central Time, 6 Eastern, of the rendezvous and grapple of the HTV-4. We'll come back on the air at 8 a.m. Central Time, 9 a.m. Eastern Time for the actual installation work that will take almost 2 hours to complete, and we're looking forward to that and the arrival of a new ship at the International Space Station. Thanks very much, Ed.
Thank you.